Yeah, all right, we're going live. All right, welcome everybody, and welcome to the solar system and the universe and everybody out there. We actually have some nice clear skies here in Tucson, so we ought to have a really good event. I'm Jim Knoll. I'm with the Tucson Amateur Astronomy Association, and I'll be the moderator here. And then Bernie Stinger, and I'll let Bernie introduce himself here in just a minute. He'll be operating the telescope, and we'll take a hard look at Mars being occulted by the moon, and then we'll hopefully go over and maybe take a look at the comet, and then come back and talk a little bit about the moon, and then wrap up about an hour after the occultation starts. We'll wrap up with hopefully Mars reappearing. Bernie, you want to say a few words before we get started?
Absolutely, Jim. Hi, everybody. I'm Bernie Stinger. I'm with the Tucson Club as well. And we're both over on the southeast end of Tucson. And I have my telescope set up in my driveway, currently looking at the moon right now and Mars. And we'll switch over to that here very shortly so that we can start to show you the event this evening. This is called an occultation of Mars. So what that means is basically that Mars in the distance is going to be covered up by the moon. And it takes about an hour for the moon to pass over Mars and for it to show Mars to pop back out again. So that should start here in about 15 minutes, and maybe 10 minutes, a little over 10 minutes. So, we're going to show you the Egress event. And maybe I could do that right now. We'll switch over to the camera view so that we can show you what the moon looks like right now. And how does that look, Jim? How's that coming through?
Yeah, that looks awesome. That's a great view of the moon. You can see the upside down lunar poodle and lots of the craters and mares. And yeah, it's looking good.
This is, by the way, those who are watching, this is a live view of the moon right now. It's almost straight up here in Tucson, so you can't beat that. And right now we've got some very good clear sky out there, which is very typical of Tucson sky. So we're all excited about that as well. Now, the moon is not full right now. It's not a full moon. It's about what would you say, Jim? About a 2/3 moon.
Yeah, I think the full moon is coming up later this weekend.
Something like that, yep. So what you're seeing now is the illuminated part of the moon. And down below, at the very bottom of the image, is where the terminator is. That's the line, if you will, where the sunlight is just reaching the edge of the moon. And below that terminator line, there is no light on the moon. So that's the dark side of the moon, the unilluminated side of the moon. So I'm going to move the camera down. I'm going to move the scope down so that the camera is going to see more of the non-illuminated side of the moon. I'm starting the pan down now. And you can see where the terminator line is. And if you kind of follow the circle of the moon, you can see that there's a good portion of the moon down below there that has no, excuse me, no illumination. So there's the moon's limb actually is way down here, far below that terminator line. And that little tiny speck of light, that little red speck of light over to the right is the planet Mars. So it's getting very close to the edge of the moon now. Let's move the image over just a little bit more to the right. We can get that better in view. How's that? That's a little better.
Yeah, that looks good.
So if you kind of follow that edge around, the edge of the moon should come down like that, probably down about there, I would say, and then comes around this way. So that's going to be about where the edge of the moon is. So what's going to happen is Mars is not moving, the moon is moving. So the moon is moving this way towards Mars. And when it reaches Mars, Mars is going to be covered up. Now, because Mars is not a point source of light like a star is, Mars doesn't wink out, doesn't just gone suddenly. Mars has a width, and because it has a width, it will slowly be covered up. And it takes about half a minute, I'd say about a half a minute. So over about a half a minute time, we should see Mars slowly being covered up by the unlit edge of the moon. I'm going to zoom in on Mars. So now you can see the disk of Mars. And there's our full disk of Mars. Now you'll notice Mars is kind of dancing around a lot. That's atmospheric turbulence. And even in Tucson skies, we still have some atmospheric turbulence. And if you look closely on the left-hand side, right about where I've got my mouse, you'll notice it's a little bit darker on that left-hand side. Jim and I talked about this. We think that's a surface feature. That's actually a darker part of Mars that is just dimly coming through. Mars
Yeah,
is,
and considering
Jim.
that is a the size of Mars is much smaller than when this occurred back in December, you're getting actually a pretty good view.
Yeah, I thought so too. Back in December, Mars was, you could actually see surface detail, but it was about twice as large as it is now. If you look up here in the left-hand corner, you can see this, here's the moon coming in. These are craters on the moon's surface that are just catching the very edges of what would be moonrise or sunrise on the moon.
We should be about 5 minutes away, so this happens pretty fast.
Yeah, again, that actual edge of the moon we can't see, but it's going to be down in here someplace. So what we have to watch for is not so much the moon's edge, but Mars itself, because once it hits Mars, then we should be able to see it take a progressing bite out of Mars. I'm going to position the moon over there so we can kind of see where the moon is for now.
And this is actually a really good way to view it, because if you would actually go outside and look at the moon, you probably couldn't even see Mars, because the moon is just going to, the brightness of it's going to overwhelm it. And so you almost have to have at least a pair of binoculars. But with the telescope, I mean, we'll be able to see it, you know, slowly get eaten.
This this event does not happen very often. It's quite rare for the moon's orbit and Mars orbit to coincide and fall on top of each other like this. And when it does happen, and I don't remember how many decades apart this happens, Jim, but when it does happen, it tends to happen in pairs, a couple of months apart. And the reason for that is the moon being in what's called its ascending and descending nodes. So this did happen back in December as well. Unfortunately, when Jim and I tried to do this back in December, the clouds decided to roll in, about an hour beforehand, and then as soon as it was over, the clouds left again.
Yeah,
For
the
some
cloud
reason,
gods
we
were
got lucky
definitely,
tonight.
yeah, the clouds were definitely not on our side last time.
Okay, we're getting up close now. I got 9:42. I don't know about you.
I do too. So a
Think
couple
we've got
minutes
a
yet.
Couple minutes yet. Where's the moon? Yeah, it's getting really close.
And I don't know how accurate that timing is. It could be off, even just, you know, certainly between cities, it's going to be off a little bit.
You bet. We've got really good atmosphere today. The very little turbulence.
Yeah.
I'm going to start zooming in on Mars. We're getting very close now.
Just kind of keep an eye on the edge of Mars, and it should just slowly, like a Pac-Man, just slowly disappear.
Yeah, coming from the kind of the upper left.
I see a few of you said that on the chat that you can still see Mars visually. That's good.
Wow, that's super.
Yeah.
I'm going to kick in my own recording here because I want to capture this.
Now, hopefully Mars doesn't make a liar out of it. Nothing happens.
I think it's pretty solid.
Yeah.
Okay, should be coming up here any moment.
Yeah, I see a little shading
Yeah,
happening
here
there.
comes.
There it goes.
Here comes.
There it goes. Like an eclipse of Mars. Yeah, down to about a half of Mars now.
Well, it is taking about a half a minute, maybe a little longer
Yeah.
even. I don't see anything that would kind of look like a mountain range or anything on the surface of the moon. It looks pretty flat.
Yeah.
Okay,
All right.
and Mars is gone.
She's gone. Yay.
Very cool. And I'm going to zoom back again. So you can see how far out the edge of the moon, the dark side of the moon was. It was way down here.
Yeah, so when we like to do observing of the moon at star parties, we like to, it's almost getting too bright because at a stage like this, it's so bright that it washes out a lot of the deep sky objects. But we do like to have a nice crescent, maybe up to a first quarter moon, because it's along the terminator that you're able to see the relief and the depth to the craters. This deep crater right at the very bottom of Bernie's view there is a crater called Copernicus.
This one here.
Yeah. And then you can see a mountain range, the Apennines Mountains right up above it. Not sure exactly how high they are, but they're probably several thousand feet high. Nice little pass or gap in the mare right in the middle of them. But yeah, with the camera, you can certainly see a lot of detail. But even visually, just zooming in on the moon, it's really cool to just kind of take your time and study the various features on the moon. And that the moon is a really great target for smaller telescopes because it just shows up so easily and it's easy to find. It's a good first object to look at. And you can get some great moon maps online or download them and actually just kind of learn about how big some of the different objects are and things like that.
We should talk about the moon a little bit. The craters are quite obvious. Let's I'm going to shift up a little bit. There we go. And maybe bring my a little bit more. There we go.
While you're doing that, Bernie, it might be good just to let everybody know what kind of telescope you are using and camera and kind of your orientation of how you're looking at it.
Right. I'm currently using tonight my Celestron 8-inch Schmidt-Cassegrain telescope. It's a reflecting telescope, and those of you familiar with Schmidt-Cassegrains, this is one of the old original orange tube, what they call the C8 Schmidt-Cassegrain. They're highly prized. This one goes back to 1980, but it's a real workhorse. Excellent optics in it, excellent figuring of the mirrors, and I wouldn't let it go for anything.
Yeah, some of the older ones, they've got some good solid optics, are really prized to have.
These dark patches are called Maria. That's Greek or Roman? I always get that mixed up.
I think that is Greek.
It stands for sea or ocean, because the ancients would look up at the moon and they'd see these dark patches. They're pretty obvious. And they thought, well, oceans on the earth, got dark patches on the moon, must be oceans. So they named them Maria, thinking they were oceans. In actuality, they aren't oceans, of course. They are huge lava beds. When the moon was originally formed, billions of years ago, enormous asteroids would slam into the surface of the moon, and they'd puncture so deep into the moon that the hole that they created would backfill with lava. The moon had molten lava back then. Doesn't any longer, but it did. So the hole would backfill with lava. And what you're seeing is that field of backfilled lava. It's billions of years old now, but there's no atmosphere, so there's no erosion on the moon. And therefore, it's pretty much the way that it was formed billions of years ago. Plus, maybe some scattered material from infalling meteorites kicking up dust here and there. I think when the astronauts landed on the moon back in the late 60s and early 70s, they discovered that there was a dust layer of an inch or two over the ground, which was basically kicked up dust from billions of years of dust settling. By the way, Apollo 11, the first moon landing. Let me see if I can find out where it was. It was always a little tricky to find. It was right about there, right about where my mouse hand is located. And this is the Sea of Tranquility. So when Apollo landed, then the first thing that they said back to Houston was, Tranquility Base here. The Eagle has landed. Because they were no longer a spacecraft, they were a base on the Sea of Tranquility. So that's why they called it Tranquility Base. And that was right about here in the Sea of Tranquility.
Yeah, when I point that out doing visual observing, I pointed out as being kind of right at the belly button of the poodle. And Bernie, if you want to just kind of highlight the poodle there and show everybody.
This is the head, and then you've got the body and a leg going back this way and another leg going that way. Is that your poodle?
And then the little fluff ball tail is at the top. So right now he's kind of standing on his head. And
right.
So right where his belly button would be, yeah. So right where his belly button would be is where Apollo 11. And then up in his neck area, just where, right down just a little bit, right in about there is where Apollo 17 landed. So that was the first and last landing on the moon. They were up in the neck area. It was probably just a little bit right at the edge of that higher stuff down below.
Down here?
Right in there. Yeah, right in there.
Yeah, it should be interesting in the near future here in a few years where they decide to land, whether it'll be on the back side or the front side.
Yeah, I think they're gonna try to target the South Polar or the polar region because they want to check out water availability,
right,
and things like that. So I think that's gonna. So we've got we have a lot of Tucsonans on the view. We have somebody in northern Colorado in the Front Range, Scottsdale. One of our viewers has an orange tube C8 that he got, his parents got in 1979. So it's about the same age as yours, Bernie.
Oh yeah, that's a keeper.
Yep, hang on to that one. Hopefully it's still working well.
Yeah, if hopefully you aren't using it on the original tripod, because that was the miserable part of the old C8. You got to take it off of that fork mount, and it's called deforking, and put it on a more modern go-to mount, and it's a really nice combination.
So you want to see if you can find the comet?
Yeah, I was just looking up the coordinates now.
Okay. We have several that would like to see the comet.
Why don't you? I think you were going to show where it was, kind of. While I'm doing that.
Yeah.
Let me release my image. And I will see if I can work my way over to those coordinates.
All right. Let me just double check something here. So what I think I'll be showing you first should be, see, yeah. So Bernie, can you confirm that they're seeing the planetarium?
Yes.
Okay, good. All right, so the comet is it's going to start fading pretty fast, and with this really bright moon out there, it's kind of hard to find visually. But I looked at it, I went out and looked at it tonight before we started, and I could see it with binoculars. It's just a little fuzzy spot. Last week I was doing a star party. I think it was Friday night, and it was showed up fairly well in binoculars, and but the moon wasn't nearly as bright. So there's a couple of key points or key objects that it's going to pass pretty close to. So that'll give you a little better opportunity. You guys can jot down the dates on these when we get a little bit further in. But so here's the comet up here. And it's kind of hard to see, but this bright star to the left of the comet is Polaris, or Alpha Ursa Minor. So that's the North Star. And you can see the smaller dots coming down here. This is the handle of the Little Dipper. And then you come down here and the bucket of the Little Dipper. These two stars right here are pretty hard to see. Most people can see these two stars at the end of the bucket of the Little Dipper. So right now, with the orientation I have on here, and I think that orientation was holding pretty true when I went outside and looked at it, the Little Dipper is kind of pointing straight down. So when you find Polaris, you look down and you should see these two end bucket stars pretty near to the horizon. And that'll give you orientation. Another way to find the North Star is you can use the Big Dipper. Big Dipper isn't completely up right now. It will as the night progresses, and this whole picture, this whole orientation will slowly spin around the North Star. So, this is set up right now for an early evening view, but if you were to go out in the morning, then the orientation of the comet to Ursa Minor and the North Star would be slightly different. But to find the Little Dipper and the North Star, you use the Big Dipper. So here's the handle of the Big Dipper, which has a couple of stars showing. The rest of the handle is down below the horizon. And then you've got the bucket of the Big Dipper. So these two end stars, we call these the pointer stars of the bucket. And they're pretty prominent. They're up above the horizon, but not by much. They're about the same height up as the two end stars of the Little Dipper. But these two stars will indeed point right to the North Star. So as you're looking at the North Star, you'd want to use your binoculars and you would want to look off to the east or to the right of the North Star to find the comet. Now, to find how far something is in the sky, one rule of thumb we use is we use our fist. And so if you were to hold your fist out at arm's length, the width of your fist is about 10 degrees. So right now, the comet is about 12 degrees to the north or to the east or right of Polaris. And in reality, it's probably up a little bit higher now. The orientation has swung around a little bit, so it's probably upper right of the North Star. Now, when you go to look at it, I use a pair of 10 by 50 binoculars. Once you start cruising around over there, it's going to be just kind of a faint smudge. That's what you're going to see. You're not going to see a nice, well-defined coma right now because it's just so diffused. Now, if you've got some really dark skies, that will help. But I was having trouble picking it out. But you'll certainly be able to see it, I think, pretty well in Bernie's telescope. So that's where it's at. It's in the process of moving up. and I'm just going to kind of move over here a little bit. So it's kind of from the North Star, it's flowing kind of, let's see, I'm going to make sure I am getting the right constellation. Oh, there we go. Okay. So it's moving up here towards the constellation of Auriga, which is visible almost straight up, but not quite. It's a little bit to the northeast of straight up. You'll see a nice circle of stars, and that's the constellation of Auriga. The brightest star, Alpha Aurigae, is a star called Capella, and that's this guy right here. The comet is heading towards Capella. And on the 5th of February, it should be just 1.5 degrees, so very, very close to Capella. And the moon won't be in the evening sky, so that'll help immensely. But the comet is also heading out of the solar system, so it's going to be dimming pretty fast. So if you've got clear skies, it's ideal to go out and look whenever you can. And then it's going to keep going up this direction, and look where it's heading to, our little occultation subject of tonight. It should get within about 1.5 degrees of Mars on February 10th. But it's going to be down several magnitudes, so I'm not sure how well it's going to show up in a pair of binoculars. But so those are two key points, the 5th and the 10th of February, that you can kind of go out and see if you can see the comet with a spotting scope, pair of binoculars. If you got a DSLR camera, put it on a tripod and try to take maybe a 30-second exposure or something that might help to show it up. And then it's going to be disappearing here pretty quick. So what I want to show you next here is, so this is kind of the orientation of where everything is in our solar system right now. And this is the comet, and this is the comet's path. So it is actually diving down through the solar system. Closest approach to Earth is going to be February 2nd, I believe. Let's see. Yeah, February 2nd is when it's going to get closest to Earth. So that's when it'll be down here. And then it's just cruising. It's moving about 1.5 degrees a night. So it's moving right along. And the orbit is on a 50,000-year orbit, but this particular comet has got such speed and such angle to the solar system that I believe it will not come back to the solar system. So it's going to exit the solar system down here, and it will just keep on going. It'll be somebody else's comet at some point in time. So this is a one and done kind of comet. So it's probably good to try to get out and take a look at it. When it gets close to Mars, over here, Mars will be coming around on its orbit, and that's when it'll be really close to Mars. And see if we can see that a little bit different there. And then the rest of the circles you see here are some of the other orbits of the planets. Let's see. It's right now it's about 27 million miles away from Earth. So it's and at the closest it'll probably get down to about 23 or so, 23 million miles before it disappears. So hopefully you'll have an opportunity to go see it. If you haven't ever wondered, or if you have wondered how they come up with the nomenclature in here, we usually have kind of two different, and Bernie, just let me know when you're ready to start showing the comet, and I'll stop talking and we'll switch over.
Yeah, I found it.
Okay.
I'm just in the, well, you can talk and I can bring up the image anyway.
Yeah, at any
It's up
time.
to you.
Yeah, let's keep mine up right now because I want to
Okay.
show the nomenclature of the comet.
Sure.
So you'll see here it's got a C/2022 E3ZTF. So this was not discovered by a person, otherwise it would probably have their name associated with it. So C stands for that it's a non-periodic comet. So you have a P, a periodic comet like Halley's Comet, and some of the ones that just means they come around in the inner solar system on a routine basis. This one is non-periodic. So that's what the C means. It was discovered in 2022. The E is how they split up the year. So, for instance, January, the first half of January is A, the second half is B. And then in February, the first half is C, and the second half is D. So this was discovered in the first half of March, since it's got E, and it was the third comet in the first half of March that was discovered. So that's what those numbers mean. And then ZTF stands for Zwicky Transient Facility. It's an automated telescope in Palomar, in the Palomar Observatory in California. I think that's in Caltech. So that particular observatory scans the night sky every couple of nights, and it records anything moving fast, anything that changes in brightness, like a radio burst or solar activity or something like that. It'll record it, and so that's how it was discovered. We have several telescopes. We have one here in Tucson, up at Mount Lemmon, that is the Mount Lemmon Sky Survey, and it's doing the same kind of thing. So Bernie, you can go ahead and start the sharing anytime you want. You should be able to override mine.
Okay, just a second.
So, okay. So this particular comet, like I said, it's moving pretty fast. If you were to take a video of it, you could probably almost see it moving across the sky.
Yeah, in fact, you cannot share screen while the other participant is sharing. Okay.
All right.
You gotta let it go for me. Okay, there you go. I guess you can take it over because you were the originator, but I can't.
All right.
Okay, here we go. There it is. So this is the famous green comet that everybody's hearing about on the news. And it's not showing any particularly bright tail right now for a couple of reasons. My field of view is only about 1 degree. Actually, it's less than, it's about a half a degree. And the tail on a lot of these comets are several degrees long. So to get a good image of the tail, you need a much larger field of view. What I'm looking at here is more the center coma of the comet. So, but it is faintly visible. I don't know if you can see it as well as I can, but I do see what appears to be maybe a stream kind of this way, and another one maybe that way, and maybe a stream this way too.
You can see a little shading out there. I don't know if you're seeing the different tails, the dust tail and the ion tail, or if it's just being diffused out. Looks more like it's just being diffused.
It does, yeah. It's hard to tell. You almost have to back off and do a wider field view of it. I would do that, but the setup that I have tonight is designed more for looking at the moon and high magnification so that we could see Mars, and therefore I don't have a wide field of view. And to change my field of view to wide field would probably take me close to an hour to disassemble it and reassemble it again. So I'm not going to do that, but we thought we'd take the opportunity to at least show you what the green comet is, and it definitely is green, no question about that.
It definitely has a green hue to it, and it is the position, the place in the sky it is right now. It's basically circumpolar, which means that it will be up for the most part throughout the evening, and night. As it gets further and further away from Polaris, and that won't be the case, and then you'll have to pick and choose when you want to look at it. I noticed one of our members, Tom Sarko's on the chat, and he mentioned there that, you know, if you wait until after like 3:30 in the morning, so if you're an early riser, the moon will be set by then, and then you'll have some dark skies to be able to try to find it again. So again, you know, it's going to be in its same rough position. It's just going to be orbiting around or arcing around the arcing around Polaris as the evening and night progresses. So, you know, if you can see the two end bucket stars of the Little Dipper, then you'll kind of know where your orientation is, and you just want to go to the right of Polaris and up in relation to the Little Dipper.
This comet is moving very fast. It's not increasing its speed. It's just because it's getting a lot closer to us. Its apparent velocity across our sky increases, and you can probably see now that I've been imaging it for what, maybe 5 minutes, and during that time you can see it's already made a dash line across the sky. The stars are staying in place. The comet is moving against the background stars, and every time my camera does an exposure, and you can see perhaps on the bottom there, you can see the exposure countdown. And when that bar reaches all the way to the right, the image is processed and stacked onto the previous image. So what happens is you end up with a streak, and that streak represents at the top of the streak the first image, and at the bottom of the streak the last image that came in. And you could clearly see that it's shifting against the background stars pretty rapidly. And this is
it's got some movement
a
to it.
half a degree field, so that's moving along.
Yeah, it is. It is definitely moving along.
The green,
Well,
by
and
the
when-
way, is because of carbon. There's molecular carbon in that within the gases of this comet that are being boiled off by the sunlight and being left behind, and that's what's causing the big green glow around it.
Yeah, when most imagers take images of the comet, when they stack them, they stack on the comet and not on the stars. And so instead of the comet streaking, you would see the stars streaking, and that's why they do that, is so they can have a good solid image of the comet, and they're not as worried about the stars and things like that. So typically, you know, when we're looking at objects in deep space, you know, the computer or the telescope is it's stable enough that nothing's moving. But when you have something moving as fast as a comet or an asteroid, and that's what these automated telescopes are looking for. They're looking for that kind of movement that you're seeing in Bernie's telescope to indicate that this is not a background star or a distant object.
Right. The telescope is locked onto the stars, and therefore you see the movement of the comet. To lock onto the comet is very difficult because you need to program in a rate of movement into your motors on the telescope that is probably beyond what my telescope could do. Perhaps some very high-end units could do that. So what we usually do to get around that problem is we instead of doing a movie like I'm doing now, we take multiple images, one image after another image after another image after another image, maybe 100 images, and then run them through a program, a software program that stacks the images so that the comet stays in the same place in the image, and therefore the stars end up moving instead, or causing streaks. And then lately, some of the software packages are even removing the stars, stacking the comet on top of itself so that it doesn't move, and then putting the stars back again so that they aren't streaked. A lot of manipulation going on there, but not something that can easily be done for a YouTube transmission like this. How are we doing for time? We've got to get back to the moon here for.
We have about a half hour yet.
We didn't talk about the egress. What we looked at before when the moon covered up Mars was called the Ingress, and now in about a half an hour we're going to have the Egress, which is when the moon uncovers Mars again. However, it won't do it on the dark side of the moon. The Mars is going to pop out on the lit side of the edge of the moon. So we'll have to move the moon on to the other end, and then watch for it to pop out on the other side. I'm not sure exactly where it's supposed to pop out, but it'll be kind of fun to see that.
Yeah, I don't think it goes in a straight line. I think there's a little bit of a curve to it, so I don't know that it'll be just on the opposite side of the moon of where it went in. But I think it'll be probably a little bit to the right of that. But yeah, it'll be interesting to see. And yeah, that'll be a lot harder to see if you were trying to watch just with your eyes, because you're going to be watching against the lit area of the moon. The glare is just going to be crazy bright.
Yeah, I'm sure my planetarium program will show me where it pops out, so we'll be on top of it.
Yeah.
Now you can see how much the comet is moved against the background stars in what, the 10-15 minutes we've been watching it.
Yeah, so that's probably, I don't know, 1/10 of a degree maybe, or maybe not quite that much.
Well, it's about you're top to bottom, you're looking at maybe 25 minutes of arc.
So roughly about 1/2 a degree.
From top to bottom, yes. No, I mean from top to bottom of my full image.
Right.
So that arc is what?
Yeah, it's probably about 1/10 of a half a degree, so about a 5%, probably a fifth, or 5%.
20, about 5 minutes of arc.
Yeah. You guys have any questions on YouTube, by all means, type them in, let us know. If there's something other than the comet and the moon that you want to ask a question on, that's fine. I don't think we'll have time to go over and do anything because we don't want to miss the egress on the moon. But I will tell you at this point that in about 10 days, on February 10th, we're going to be doing a virtual star party right here on our YouTube channel. This you should have probably saw when you came over to our channel. The event is sitting there counting down. That'll be on the 10th. We'll have hopefully 3 telescopes hooked up, and we'll bounce around and look at some various objects in the night sky. And since that is technically when the comet should be close to Mars, we'll probably try to make that one of the events that we look at. But we'll just talk a little bit about cosmology and astronomy and hop around. But that'll be February 10th from 7 to 9 Tucson time.
How much time we got here? We've got 10:20 and it reappears at
About 10:45.
10:50.
Yeah, someplace right in there.
You know what?
10:45. 10:50.
Bodes Galaxy is just a little hop, skip, and a jump here. Let me see.
Yeah.
Do a
I was
little
gonna.
jump over there.
Yeah, well, in fact, if you want to keep sharing your screen, maybe these guys can then see what it looks like when you're moving. We can talk about
Sure.
that a little bit.
All right. Well, I've on another screen here, I've programmed in the telescope to move over to a very well-known galaxy called Bodes Galaxy. And it's a real pretty galaxy to look at in binoculars or a telescope. So, and it's very close to the comet right now. So I'm going to do a quick shift over there, see if we can find it. Well, I'm in the process of telling the telescope to move. Before I do that, I'll kick in I'm going to cut down on the exposure time. So you're going to see it dim down a lot here as I do that. Because I don't want to overshoot what I'm going after. There we go. All right. So here we go, off and running. I'll move over to Bodes Galaxy. So you're going to see a bunch of streaks in the image. Those are the camera taking pictures as the stars fly by. Oh, there it is. See if we can bring
Yeah,
that
maybe
a
you
little
can even
higher.
get both Bodes and cigar in there at the same time.
Yeah, maybe. That can kind of get a little tough. I'm not sure where the cigar is in relationship to it.
Yeah, you'd have to probably do a little looking around, so that's fine. I would just do Bodes, and if we get an
I'll move it
opportunity, you
over
can
here
do
to
a
the
quick.
other corner, see if it makes any difference. No, it's not over there.
Yeah, it's probably just outside your field because I think it's about a degree away or maybe half a degree away, so it's probably really close. A lot of times when I'm doing visually for a star party, I can get them both in the telescope, and that's kind of fun because Bode's galaxy that is at the bottom of Bernie's screen there is a face-on galaxy, and then the cigar galaxy is an edge-on galaxy, so you can see two different views of two different galaxies.
I don't remember well enough where Bodes is. I don't remember the star fields quite well enough to know where
Which way you got to move
cigar
it?
is in relationship to it. All right, let's see if we can work with this here. So I'm going to kick this up a bit. A longer exposure.
Yeah, it's starting to come in a little bit stronger.
We'll try about 20 seconds. All right, let's see how that comes in. Too much red. I get a lot of reddening of my images because of sky glow, so I have to try to manually compensate for it. There, that's better.
Mm, yeah.
All right, now I'll do a little stacking and see what happens. That usually helps. Are we holding on to our audience or are they dropping out on us? It's getting late in the night.
No, everybody's hanging in there pretty well. We've got 31 viewings, so appreciate you guys hanging out with us. So yeah, AA asked, will Mars be beside the moon tomorrow night? And the moon moves about make sure I get this right, 15 degrees a night. So again, if you hold out your fist at arm's length and do like a fist and a half width, and that's about how far the moon will move. So it won't be right next to it. It'll be separated some, but it'll be still in the same general area.
Well, considering I'm in Bortle 6 sky here, which is a fairly bright sky glow in my area, it's coming through fairly well. This is the central core of Bodes galaxy, obviously. And Bodes galaxy has two fairly prominent arms. So it forms kind of a figure S in the sky. And if you look, let me see if I can go to a full screen view. Sometimes it makes it show up a little better. There we go. How's that look? Any different for you?
No.
Okay. Well, there's one arm that comes around this way. You can see that upper arm is more obvious. So here's one of the spiral arms of the galaxy coming up this way. And then the other spiral arm, you can kind of see the concentrations of it coming around down here, and it swings around back down this way. So it forms a big kind of S curve, one going that way, the other one coming back around this way.
Bernie, I don't see your cursor moving. Could be
Oh, you
me.
don't see my cursor at all?
No, I don't see it moving. So again, it could be me. Not sure how it's looking out on YouTube. See.
You see it now? Is it moving now?
Yeah, now it's moving.
Okay.
Yeah, I think it just got hung up there for a little while.
Oh, all right. Well, this is one of the arms. It comes around this way. You can see the faint arm. And then here's the other arm, comes, swings around this way, comes up and under and back around this way. So forms a big S with the central core being the center of the S. I tell people, I call it the Superman galaxy because it looks like a big figure S in the sky.
Yeah, but you're starting to be able to see the spiral arms a little bit better as it stacks. Well, maybe we should get back to the moon, huh?
How are we doing for time?
Yeah, about
30,
15 minutes.
10:30, 10, okay. Let's do that.
Yeah, when we do star parties or astronomy events, like I said earlier, we kind of like to have just a crescent moon, a small moon. Now, once it gets past about first quarter, it really starts making it hard to see deep sky objects because the moon's just natural light pollution, and so once it gets to a full moon, it not only is it really bright, but it's like taking pictures at high noon. Everything's flat, so you can't really see any detail to the craters or the mountains. So it's not nearly as exciting to look at as it is when it's a nice crescent. So usually when we're trying to do events, we lean towards either having a small crescent moon up to about a first quarter, or if we do it around a third quarter moon, then the moon's not coming up until the wee hours of the morning, and it's up during the day, and so then it doesn't really matter as far as evening star parties go. And then we'll also try to do stuff around the new moon.
Should have moon up here in a moment.
There it comes.
Oh, wow. All right, a little overexposed. Bear with me. If we can tame that down a little bit. There we go.
Yeah, when it's this big, when I'm doing visual astronomy, I'll usually put a filter on the eyepiece, the polarizer filter, just to cut down the brightness, because otherwise, just trash your night vision for 10-15 minutes. You won't be able to see hardly anything out of that eye. You're looking at the moon.
Right. Let's see now. It should be trying to discern where it's going to pop out. It's going to come out. I need to move over a little bit. To go up. This one.
I was thinking it was going to kind of come out about where his the poodle's tail is, but I'm not sure.
Yeah, I can see where the moon is behind it right now. So currently, the moon is I'm sorry, the Mars is right about here.
Okay. Yeah, that looks about right.
And I'm guessing it is going to pop out someplace over in this area.
Yeah.
Judging by the current motion. So let me move it over in that way and go to the left. Oh, wrong way. Too much. And maybe bring it down a little bit. Someplace over in here, I would think. I need to move that over just a hair more.
Yeah, and we're probably still about 10 minutes away.
Ah.
And as Bernie's kind of tweaking that and you're looking at his moon image, you can see some bright spots on the moon and some what we
Right
call
here in this one.
rays. Yeah, rays coming off. Those are some of the younger's relative, but those are some of the younger asteroid hits and impacts on the moon. And so that's just fresh regolith that you're seeing there. It hasn't been dirtied up by the solar wind.
This one kind of shot it that way, and that way, didn't it?
Yeah, yeah.
It's almost
That
like
must
there
have
might have
been
been a mountain, something here to block it from flying in
right.
this direction.
That was probably a pretty steep impact since it's going out symmetrical around all different sides. You know, if they come in shallow, you'll see a long ray heading out one direction or another.
Do you know where that one hit was that bounced? You ever seen that one? Jim O'Connor showed it to me once. It almost looks like something hit on such a sharp angle that it kind of bounced a couple times before it finally settled. Either that or it was a string of them that all kind of fell all at once. I'm gonna have to look around, see if I can find that again.
Yeah, usually when I'm showing the moon and I kind of show picture of the poodle, and then I explain it to people and then let them look, and it kind of jumps right out at you once you see it, and it looks kind of like a show poodle, you know, that's been trimmed for a dog show or something.
Trying to position it just a little bit better.
Yeah, that should be
Oh,
good.
again. Yeah, somewhere in there. Gotta be.
Yeah, it's probably still another 5,
Mhm.
6 minutes away. I think it was 10:50 our time, if I remember right.
Yes, that's what I have here. 10:51. Right now it is.
And 42, so yeah,
It's
about 9 minutes.
same direction as that. So yeah, it's right about here right now.
Okay.
Like it's gonna come out up here someplace.
So is this kind of like watching grass grow? We're waiting.
Not quite as exciting as a solar eclipse, is it?
No. Yeah, speaking of that, we got a couple of solar eclipses coming up here. There's going to be an annular eclipse that'll be scooting across northern Arizona in October. And that's where the moon doesn't quite cover up the sun, and there's a little ring around the sun. And then we got the total solar eclipse next year. God, I can't believe it's here already. April 8th of 24.
Yeah. Boy, it's just a little over a year.
Yeah.
Do you have anything lined up, place to go?
No, I haven't. I need to figure that out.
I would assume you'd be going up with your trailer, with your mobile home.
Yeah, I'll probably go over to Texas someplace.
I might tag along with you.
Yeah.
If you don't mind.
No, not at all.
definitely want to see that one. And Texas sounds like the best place to go.
Yeah, yeah, we were.
The annular too, later this year. Are you thinking of going to see that?
Yeah, I'd probably go up to northern Arizona someplace to see that. Up in the Four Corners area, I think is a good spot, or up into northern New Mexico. I haven't seen one of those. I've seen a couple of the total eclipses. We had one that came through um, Montana State when I was going to college, so we didn't have to go any place for it, and that was pretty nice. And then the last one,
I've seen 3 solars now. One in 79, I believe it was, in Manitoba.
yeah, that's the one that came through Montana State, was in '79.
Yeah. And one that came through Minnesota back in, I'm really going to show my age here, probably around 55, 54, 55. I'm going to say somewhere in that time frame. And then, of course, the last one. So this will be fun to see. I saw an annular many years ago, probably back in the 80s, down in Georgia.
Hmm.
That was kind of
Yeah,
fun.
I have not ever seen an annular.
It just gets dark and then it gets light again, but it's kind of fun to see the ring.
Yeah.
Okay, it's getting close to the edge.
Yeah, a couple more minutes yet.
See if I can define where it's going to come out here a little better. Follow this one across. And then the other. It's going to be right around in here. Right around in here. I'm going to bring my exposure time up a little higher because we need to be able to see Mars. So it'll overexpose the moon limb, but if I don't do that, we may not see Mars at all.
Want to try zooming in, Annie, or do you want to keep it here until we see it, just in case? You
Yeah,
might be able to get
should be right around in here someplace.
so you might be able to zoom in a little bit if you wanted to.
Yeah, a little more. It's very close now.
Should be any time. Yeah, I wouldn't get too close, just in case you miss.
Well, we ought to see it, kind of a little lump showing up. What's that?
There
Right
it is.
there?
Yeah, right there. I think that's
I
it.
think
Yeah,
so, yeah, yeah, I think so, yep, there it is.
here she comes.
Boy, there's a lot of atmospheric going on now.
Yeah. Yeah, that would be really tough. I don't know if anybody's outside, if you can see it visually or with binoculars, but it's against that bright moon. It's probably pretty
Oh,
tough to
no
see.
way, no way. I don't think binoculars would even do it. Almost looks like it's styrated.
Yeah, it's kind of a, a simple phenomenon, but it's just kind of cool. Like Sarah says, it's just kind of cool. Sometimes
And
you don't,
probably
you
won't
don't,
happen again in our lifetime, so
yeah.
fun to catch.
Yeah, I mean, the moon probably occults lots of stars and things like that, but you've got to just be looking at the right time to be able to see it. But planetary occultations like this and conjunctions, any kind of conjunction is kind of cool to be able to see.
Kind of like the conjunction of Jupiter and Saturn a couple years ago.
Yeah. Yeah, we did a live stream for that. We had probably about, I don't know, what did we decide, about 550 people
Oh, there
watching
was
that
a
from
lot of people watching.
all over the world. That was kind of a fun one to do. So yeah, so we'll wrap this up here pretty soon, but we appreciate everybody checking in with us, and just kind of keep an eye on our YouTube channel. We post our meetings there once a month, so there's some pretty good talks that we have coming up that are fun to be able to watch. You can watch them on either our Facebook or our YouTube channel. YouTube we tends to have a little better quality picture, I think, than Facebook. So, but for sure, come back and join us February 10th, 7 to 9 p.m. We'll do another virtual star party with a few telescopes, and hopefully we'll have some clear skies. If we don't, we'll try to post something either on Facebook or on YouTube, or come and do a quick stream to just tell everybody, yeah, sorry, we got clouded out. But usually we're pretty good here in Tucson. Most of the time we get some pretty decent skies. And if you're in the Tucson area, certainly come to any of our public star parties and come check them out and do some live viewing. And we've got the Grand Canyon Star Party coming up in June 10th through the 17th. And that's a lot of fun because we'd set up about 60 to 70 telescopes a night for 8 nights. And I mean, you get some incredibly dark skies, and you're up at 7,000 feet. So, I mean, the band of the Milky Way is just brilliant up there.
One horizon to the other.
Yep. Bernie, any final thoughts?
Well, this has been great fun. First time I've been able to do this as a live stream, and I think it's enjoyable to show it to other people too, as long as we're enjoying it. And glad for everybody who hung in there with us, picked up the not only the Ingress but the Egress, and both of them showed up. We were worried about weather coming in and kicking us out, but we got lucky and it stayed clear. So we're happy.
Yeah. Absolutely. All right. Well, thanks everybody for coming, and we'll try this again in a week and a half or so on the 10th, and check out our Facebook page as well if you want. We'll think clear skies and keep looking up and watching the universe go by.
Thanks for showing up. We appreciate
Good